right, so today we are looking at the lab, Newton's first and second laws of motion. We need to complete this table here for 1, 2, 3 different carts. We have their data is all up here for each cart, and the experiment operates like this. We have a cart that's moving. It starts here, it goes forward, it crosses gate A. That will give us a time when it first crosses gate A. It will leave gate A, as in it enters the light, it leaves the light. So starts, hits the light, leaves the light. But more importantly, we need to know how long does it take to go from A to B, and that's where the first question comes in. Time. Photogate 1A, photogate 1A, so you take that time, and you're going to find out how long it took to get to gate B1, which is right here. So basically super simple. You're going to take this time and subtract that time and find the difference. And in this case, the difference is going to be 0.648583 seconds. Second, we need to find the time that it took to go across. It enters the photogate B, and then it leaves photogate B. So basically what it's trying to find out is how quickly, as soon as it crosses the light to start with, how long does it take to go all the way across the light and then the end of the cart to get fully across it. And so we have those times provided to us. This is when it entered gate B, this is when it left gate B. So again, take the higher time and subtract the first time. T2, T1, subtract, and we're going to end up with the number . Okay, now to calculate, we have times now, but we need to calculate the velocity, the final velocity as it was going across gate B. That's where it's going fastest. It was going slowest here, accelerates, 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 and then it's going at its fastest speed right here as it goes, starts gate B, leaves gate B. That's the fastest speed. And we are given the calculation right here to find the speed at gate B. The cart is 0.01 meters long, and we're going to divide that by the time it took to break the beam at gate B. So basically, we're going to put right here, V2 equals 0.01 meters, and we're going to divide that by this time. I'm going to put that right here, divide by 0.004633 seconds, and then when we get our answer here, it will be 2.1584. It goes on longer, but I'm cutting it off here because it's just getting too messy. So here's our V2 speed. It is 2.1584 meters per second. There is one other step that we have to do here. We have to find out what was the acceleration, the theoretical acceleration. And we actually have to go back to the previous page, the first page, and right here, question number 8. Use Newton's second law to calculate the force of a 0.05 kilogram mass on the string, and we're going to assume that gravity is the acceleration. So if F equals ma, we're going to plug in 0.05 to the m, and we're going to put this to the g, do the math. We end up with force equals 0.4905 kilogram meters per second squared, or that's 0.4905 newtons. So we need this to be able to do the theoretical calculation. We'll come back here in a moment. Let's calculate how do we do acceleration of the experimental portion. Well, again, right here, the fourth column is to get us the experimental acceleration. We're going to take V2, which is right here, and we're going to divide it by the time that it took to go from gate A to gate B, Oh, guess what? That's right here. This one is T2 minus T1, gate A to gate B, and it was that. So we're going to, I'll write it down here. Acceleration equals V2 divided by the difference in time. And we have those numbers. It's 2.1584 meters per second squared divided by the time. I'm sorry, that one is not squared yet. That's just the velocity. So it's meters per second. And then we're going to divide it by the total time it took to go across, which was 0.648583, and that's seconds. So when we get to the end, acceleration equals 3.32791 meters over seconds times seconds, or what we can call seconds squared. So that is our experimental 3.2791 meters per second squared. But now we still have to do this last one. Now, when you're doing this one, you have to take the force is going to be the same. We need to calculate the acceleration. We don't know that, but we do have the force, and the force is going to equal, from our very first page, we did it on question number 8. We calculated the force is 0.4905. Force is 0.4905, and then the mass is going to be how much did the cart weigh. So if the cart weighs 0.1, we're going to do that. F is that, divide by M, 0.1 kilogram. And we want to find out, I'm going to get rid of that. We want to find out A equals this force divided by that. And we're going to end up with A equals 4.905 meters per second squared, because it's acceleration. 4.905 meters per second squared. Congratulations, we've completed it for cart 1. You will repeat this again, but you'll follow the data points for cart 2. You'll use the same force. Force is going to be equal, the exact same number. Force equals 0.4905 for every single one of these. And you're going to do it force divided by the mass for each of these. So you could run those calculations right now for each different cart weight, but you're going to have to do the times for this car, times for that car, and move all the way across as we just did.